Yes, sir, you are audible.
Okay. So next 1 hour or so, I would be trying to discuss about our space-based observations for disaster management support as well as for climate change studies. Anyway, introduction is given about me. So I will straight away move to the topic. So what I plan to do is that I will first speak about our disaster management support program and try to explain how space technology is supporting disaster management in the country, and then I will move to the climate change inputs. So you might be wondering why should be worried about disasters, and you very frequently hear these terms. So first, I would like to introduce three terms to you. One is hazard, next is vulnerability, and third is risk. So hazard is the probability of occurrence of a potentially damaging event in a given time and location. So the vulnerability means it is the degree of exposure of particular element which is at risk, and the integration of hazard and vulnerability will give you the risk. So these three terms, uh, uh, I request you to just remember these three terms: hazard, vulnerability, and risk. This is common terms that we come across in the presentation. Second, disaster management is basically it's a cyclic approach, uh, because from the moment the disaster occurs, your action starts. I mean, it is not that your action starts at that point of time. You need to be prepared. Then there is occurrence of the disaster, and then your response for that disaster, and then the post disaster, whether it is rescue, relief, and then rehabilitation, and then you get prepared for facing suppose disaster occurs in the future. So it's a cyclic process. Disaster management is a cyclic process. With these two three minor introduction, I would like to move on to our topic. Our country is experiencing disasters on a recurrent basis. Could be because of its geographic disposition, or could be because of its tectonic characteristics. And you can see that nearly 12% of our land area is, vulnerable to floods, and we have about 7,500 kilometers of coast which is vulnerable to cyclones, and nearly 25% of our area, our land area, is prone to seismicity. That means they fall in seismic zones 4 and 5. Then other disasters like 36% of the forest area is actually prone to forest fires, and there are landslides in the hilly terrain that comes around 12.6% of our land area. Now, we see that these disasters are occurring on a recurrent basis, and as per the United Nations assessment, there is nearly 3 to 5%, 5 times increase in the average number of medium to large scale disasters that has been occurring since 2000 when we compare with the figure that had been occurring during 1970 to 2000. And we also, since we have climate change also as one of the topics today, you know that climate change also influences disasters in the form of increasing the likelihood, frequency, as well as the intensity of climate related hazards. And also the climate change tries to alter the exposure pattern of various hazard events, so that we hear occurrence of hazards in newer localities which were hitherto unknown. And you can see that since 2000, if you one assessment was done regarding the loss of various losses in the country, and we can see that nearly more than 12 lakh crore rupees is the economic loss associated with various disasters in the country. And more than that, what is really worrying is the loss of precious lives. More than 86,000 lives were lost during this, since 2000. And in 2023 itself, if you recollect, there were major floods in northern part of the country, especially in Himachal Pradesh and Punjab, Haryana, and we also remember in Sikkim on October 4th there was a particular event called Glacial Lake Outburst Flood or GLOF. And that also did cost nearly 88,000 people were affected and more than 100 people died of this one. And if you look at the statistics in 2023 itself, uh, more than uh, 11, 1,100 lives were lost in the country. And most of these were attributed to basically due to floods, and then lightning is another disaster. And you also see that our country is having a very good disaster management support program, and it is a mitigation and preparedness driven approach that the country has adopted. And these are actually basically driven by the Prime Minister's 10-point agenda for disaster risk reduction. And also, the disaster management is actually enacted in the country in terms of law. That is, we have the Disaster Management Act 2005, which really created the National Disaster Management Authority, NDMA. It is a, this approach is a three-tier approach. We have at the central level, we have National Disaster Management Authority. And then further down at state levels, we have state disaster management authorities, and, drop down to district disaster management authorities. So this is the profile of our country, disaster profile, and what is our approach for disaster risk reduction. I was telling about the disaster management cycle. On the right hand side of the screen, if you see, I have kept a few terms. One is HVR assessment, that is hazard, vulnerability, and risk assessment, which I explained in the beginning. So, then there is a forecast and nowcast. That means this also comes in the pre-disaster phase. And then during the disaster, basically, you have to detect, you have to monitor the disaster, and also you have to assess the damage. And then post-disaster, the lowest segment is the relief, rescue, and rehabilitation. And then the entire process repeats, like hazard assessment, forecasting, and then the unfortunate event of disaster occurrence. So this is the cycle of disaster management. And then what I would like to explain here is how space technology is giving input for supporting these activities at all the three phases of disaster management. You might have heard about various types of satellites in the previous lecture. So the first input which goes is the satellite images, both in the optical, thermal, as well as in the microwave domains. And these land remote sensing satellites are very helpful for assessment of the hazard, vulnerability, and risk. And we also have satellites for atmospheric observations, and also basically these are meteorological satellites. And in addition to that, we have satellites observing ocean. I will explain these satellites. I have a slide on that. So these satellites basically, help in the monitoring of various hydrometeorological disasters. And third input is that we have digital elevation models that can be prepared using Earth observation. So that also goes as an input for various modeling of various events. So, and this is how that is the space technology goes as an input for various phases of disaster management cycle. So once I have moved to the next slide. So once we understood the potential of space technology for disaster management, ISRO initiated a program called Disaster Management Support Program. And the main objective of this program is to make the space-based inputs available for disaster management by the respective nodal departments. So the role of each of government departments is actually defined. There are something called allocation of business. So for ISRO or Department of Space, our role is to make these space-based inputs available. Whereas the nodal department for various disasters, they use these inputs and then carry out the disaster management support. For example, if it is flood, the Central Water Commission (CWC) is the nodal agency for giving flood forecasting. And if there is a unfortunate event of large scale flood event, then the Ministry of Home Affairs is actually into the management of that disaster in terms of rescue relief. You might have seen the National Disaster Rescue Force (NDRF) comes into act at that point in time. So our disaster management support program is basically centered around a decision support center, DSC, that is established at NRSC, National Remote Sensing Center, Hyderabad. And one of the major activities that is being carried out as part of this disaster management support program is near real-time monitoring of various disasters as well as the damage assessment associated with the various disasters. The second important point is we have established a multi-scale database, national level database called NDEM or NDEM. So that goes as an input for emergency management by the nodal agencies like NDRF or SDRF. Then we also support in development of early warning systems by providing necessary space-based inputs. Then most importantly, the disaster management support program is in continuous liaising with various central and state government agencies. For example, we are in liaising with the Ministry of Home Affairs, National Disaster Management Authority, then Cabinet Secretariat, and also various nodal departments for various disasters. And I would also like to bring it into your notice that the disaster management support program has, has got commitment with the various international forum, which have common goals of providing space-based support for disaster management. And I have indicated the major disaster types that are being supported by our program: floods, cyclones, forest fire, then drought, landslides, lightning, and earthquakes. These are the major disaster domains that is being addressed by the department. So I'm moving to the next slide. So let's have a look at what is our space-based, what is our national infrastructure for supporting disaster risk reduction. I was telling about, you might have got a fair idea about the different types of satellites. So the Earth observation satellites are actually basically what I'm going to talk about is how the disaster management support is given through Earth observation satellites. We have something called ResourceSat series of satellites, which can image 3 types of images at concurrently. That means at 56-meter resolution, 23-meter resolution, and at 5.8-meter resolution. And these images from the ResourceSat series is actually going to various, hazard, vulnerability, and risk assessment. And these are basically used for preparing the hazard maps or even monitoring the disasters. We also have something called the Cartosat series, which are very high resolution images. We can image up to around 60 centimeter resolution with the Cartosat, about 30 centimeter resolution using the Cartosat 3 series. And this basically goes for damage assessment and also for hazard or vulnerability assessment. Then we have the OceanSat series of satellite, which basically give observation about the ocean surface wind vector and also ocean color. And along with this, we also have the INSAT series of satellites. Basically, these are weather monitoring satellites. So the INSAT series as well as the OceanSat series are particularly useful for early warning of tropical cyclones. And then in addition to these satellites, okay, before that, I just want to indicate that we also have a series of microwave imaging satellites called radar imaging satellites or RESAT series of satellites, which have all weather as well as day and night imaging capability. So this type of microwave images are particularly used for support during the flood season, especially during the monsoon season. In addition to these Earth observation satellites, our space department also has satellite communication and satellite navigation based support for disaster management. And there are also, we have a capability for acquiring data from aircrafts as well as from unmanned aerial vehicles. These also are particularly useful for generating high resolution database for disaster management support. So after telling about this much of background, I would like to move uh, in describing how we are supporting various disasters. I mean, for management of various disasters. Let's look at how space-based support is given for managing floods in the country. You know, the National Remote Sensing Center at Hyderabad has been mapping the flood inundation almost near real time for the last 25 years or so. So this helped them to create a very good archive of flood inundation in the country over a period of more than 25 years. So using this input, they have come out with two particular products. One is flood hazard zonation atlas. That means for about six most frequently flooded states like Assam, Bihar, wherein we see floods almost every year, we have prepared something called Flood Hazard Zonation Atlas. We can see on the right hand side top. It categorizes the area into the hazards, different hazard categories like very low to very high hazard. How it is helpful for the management? So it is basically based on the frequency of flooding. That probability is based on how frequently these areas had been flooding in the past. And using this input, the management is able to, suppose they want to go for some developmental activities, they can avoid such high flood hazard areas. So that is one input. Then there are other states which are not as frequently flooded as these states. So for those states, what we have done is that at national level, we came out with something called flood affected area atlas. So it is a cumulative database of flooding over 25 years. So that also helps the administration to take decisions while going for any planning, or they want to do some regulations implemented in the state. Then now I told about hazard, vulnerability, and risk. So suppose you have long-term meteorological data like rainfall, last 100 years rainfall data. You can also find out what is the return period of different rainfalls of different intensity or frequency. So you can find out how vulnerable over a period of time, maybe for next 50 years or 100 years, what is the vulnerability of flooding. So that is the third product that has been generated, flood vulnerability mapping. So now we have hazard vulnerability. Now we are developing the flood risk assessment. You can see on the right hand side bottom the flood risk map of Bihar. So the flood risk will basically consider various elements which are exposed like population, infrastructure, etc., which are exposed to the flood the flood hazard. The next, so that is the first type of input based on historic flood data, the flood basically the flood hazard. The second is that for managing flood, if you are able to give early warning, that will be very helpful. So ISRO has developed something called a spatial flood early warning system for two important river basins. One is Godavari River and second is Tapi River. And this development also has used mainly space-based inputs. And one important input that has gone into this system is very high resolution digital elevation model at centimeter level. That means the advantage is that you can find out which areas are going to be flooded and how much is going to be the flood depth in advance. So next 3 days, next 72 hours, you will know which are the areas which are going to be flooded. So that information you give to the administration, they can do the necessary evacuation. So this early warning system is developed by National Remote Sensing Center on behalf of Central Water Commission, because I was mentioning ISRO's job is to create such models, but acceptability of the model depends upon the nodal department. So CWC has endorsed these models and now they are utilizing it for operational uh, release of flood early warning. The third important aspect with respect to floods is actually, I was telling about near real-time mapping about mapping of flood. So with the satellite data, today we are able to map the major floods in the country, and you can see that over the years, nearly maybe 12 to 14, 12 to 15 states of the country are facing major floods every year. So all the important major floods are near real-time mapped using satellite data, and this process is nearly automated. So the satellite data, as the satellite data is downloaded in the data center, that algorithm runs and it generates a flood maps, and then that flood maps is actually given to various flood management organizations like CWC or even to National Disaster Management Authority, and they will do the intervention. So our job is to generate this product and disseminate. And that's about the mapping or near real-time monitoring of floods. So these are the three important activities I have explained about flood hazard zonation. I explained about the flood early warning, and third one is flood mapping, near real-time mapping of floods. And let's move on to how space is supporting the management of tropical cyclones. You know, you might have heard about the super cyclone in Odisha in 1999, and wherein more than 10,000 lives were lost. But similar type of cyclones, when if they occur today, you see that the loss of lives is limited to maybe a single digit. So this entire effort is because of, since our India Meteorological Department could establish very effective cyclone disaster management in the country. And satellite data is one of the important inputs into their cyclone early warning system. And what IMD estimate has estimated is that one, of course, is the uh, drastic reduction in the number of loss of lives. But in addition to that, they are able to reduce the area of evacuation by almost 300 kilometers in the last 20 years, and that also resulted in significant reduction in the cost of evacuation. So, and both in terms of loss of lives and in terms of economic benefit, this cyclone early warning system has helped the country. Now, how space is supporting? Now, I would like to mention that there are three types of inputs going into this cyclone early warning system. One is the data from our weather monitoring satellites, INSAT series of satellites, which basically help real time, because you might have seen IMD gives INSAT image, near real time image. So every 15 minutes, when there is a cyclone, we are able to do that monitoring. But in addition to that, the INSAT series is also capable for rapid scan every 4 minutes. That means if there is a cyclone, you can operate these satellites at every 4 minutes and you get the information. And the data from this is actually going to also going into the forecasting of cyclones, its track and its intensity and likely landfall location. The second type of input that goes into this cyclone early warning is actually a type of data, something called scatterometer. Basically, this gives the ocean surface wind vectors, both its velocity and direction. And how it is helping, using this, you can see on the right hand side, this scatterometer derived wind vectors help cyclogenesis prediction. Before the formation of cyclones, official declaration, you will be able to know the cyclone is going to form. Second, it's geolocation, how that cyclone is moving. That information also you derive from the scatterometer data. And over the years, it has shown that it has got 100% probability of detection for nearly 72 hours of lead time. And the third input is actually the humidity, atmospheric humidity from the satellite-based observation. So this actual responsibility of this system is by IMD, whereas ISRO is also doing carrying out research and R&D activities. How we can improve the use of various satellite-based inputs for developing new algorithms for early warning of tropical cyclones. And you can see on the right-hand side how we have used the scatterometer, the wind vector data from the OceanSat-3 satellite for the tropical cyclone Biparjoy that hit our western coast in June 2023. And SAC Space Application Center at Ahmedabad is actually engaged in developing such algorithms, and they could predict the formation 18 hours before the formation of the cyclones. And SAC also got this something called the Lagrangian track prediction model, and they could predict the track of the satellites, which had shown very close match with the observed track. And even the landfall location and time was also predicted very accurately. So this is how ISRO is engaged in the management support for disaster management with respect to tropical cyclones. I move to the next important, disaster management support, that is regarding forest fire. Nearly 3.7 lakh hectare forest in the country is actually prone to forest fires, and uh, we, we have space-based capability to detect the anomalous temperature because the thermal remote sensing is able to detect thermal remote sensing in both shortwave infrared as well as thermal infrared regions are able to detect the thermal anomaly associated with forest fires, and there are global observation systems which give the satellite data for such monitoring. And we have established ISRO has established an automated procedure located at NRSC Hyderabad, and our Indian forest fire season is basically extending from January to June every year, and nearly 6 to 8 times we are able to detect these active forest fires on a near real-time basis. That means within 30 to 60 minutes, 30 to 60 minutes of the satellite pass, we are able to generate that forest fire detection. And you can see the sketch on the right-hand side. So the detected forest fire information is actually transferred to Forest Survey of India at Dehradun, which is the nodal agency for forest fire management in the country. They generate from using this, they generate state-wise forest fire detection, and it is given to their field officers for validation as well as for management activities. Satellite data is also used for assessing the burned area after major fires or seasonally or after a decade. So that is the second important activity. And now the research is basically into developing forest fire risk index. Basically, you would like to know, based on the weather condition as well as based on the type of forest, what is the fuel condition, whether you can kind of forecast what is going to be the likely spread of a particular forest fire. And we are also carrying out research in identifying such long duration forest fires on an automated basis. You can see that the lower portion, identification of long duration forest fire events, and these detections are actually it's an automated. Now it is implemented for Odisha and is being extended for other states in the country. I will move to the next disaster, that is landslides. During the rainy season, we hear that in the country, especially in the Himalaya and in the Western Ghats, we have many landslide occurrences. And how we are supporting, there are two important activities. One, we are able to generate an inventory of landslide, and our NRSC National Remote Sensing Center has generated a semi-automated approach for generating such landslide inventory. And over a period of time, this landslide inventory we have used for generating a landslide atlas, which was released in last year. So this contains data for almost 22-24 years. And second, if there are large landslides, then we also do the damage assessment for those, how much is the area affected in terms of agriculture or losses of house, etc. The third activity with respect to landslide is the landslide susceptibility mapping. For example, for all the major pilgrimage and tourist route corridors in Uttarakhand, Himachal Pradesh, as well as in the northeastern region, we have used the various inputs like like the rock type, like the vegetation, then presence of joints or fractures in the rocks. Then all these are integrated and identified how susceptible one location is for landslides. And now the activity is integrating whether if we are able to forecast the occurrence of rainfall, the occurrence of landslide, if we are able to get some information about the likely rainfall that is going to happen. So since rainfall is one of the major triggering factors, we are now doing research for developing some sort of early warning system for rainfall induced landslides. So I move to the next disaster, that is support for earthquakes. And with respect to earthquakes, still, prediction or early warning for earthquakes is really tough. However, we have understood that most of the earthquakes are associated with major tectonic features like active faults. And satellite data, you can see the top left image. The satellite data gives very good synoptic coverage, and you are able to map such active faults which could likely be, reactivated, and which can result in earthquakes. Satellite data is also able to map something called the deformation. There is some, technique using the microwave remote sensing data. You can really find out how much is the deformation of the surface. And you know that the terrain like Himalaya, there is ongoing deformation. But at what point in time that deformation will actually lead to an earthquake, that uh, is the crux of the problem that is still being addressed. And if there is an earthquake on the right hand side central portion, you can see that co-seismic deformation. That means when there is an earthquake, you can see that there will be large destructions or displacement on the surface. And satellite data, the technology of interferometry using microwave data could also find out the deformation associated with the earthquakes. Then obviously the damages due to the earthquakes could be assessed using very high, that you can see on the lower left image. You can see high resolution data is helping the damage assessment for earthquakes. So this is how we are supporting the management of earthquakes using satellite data. Then after this, I would like to bring into your attention that ISRO has also implemented something called a national database for emergency management, because various agencies like NDRF or any agency would like to take some decision. They would need a very reliable database, and at multiple scales, at country level and at district level and at city level, multi-scale database is generated. So it includes all the infrastructure, roads, and all the information is available. And this NDM dashboard, if you can see on the right hand side, it really gives the current status of disasters in the country, and it also broadcasts the forewarnings from major agencies like CWC or IMD or inquiries regarding various disasters like floods or earthquakes or coastal inundation, etc. And then this system NDM also has got tools for decision support. For example, you can find out if there is a disaster, what are the nearby hospitals, what are the nearby schools for relief or rehabilitation, etc. And then it also will give damage statistics. If there is a flood, how much is the area inundated, how much, which are the houses affected, etc. So this information is available, and the Ministry of Home Affairs is actually, this was developed by ISRO on behalf of Ministry of Home Affairs. And I would also like to mention about our one particular initiative for the northeastern region that is called Northeastern Regional Disaster Risk Reduction, and it's a replica of all the activities, but there are regional initiatives like I would like to mention that there is a flood early warning system that is developed for the Brahmaputra River, and this was established in 2012, and with the funding support from the state of Assam. And there are other initiatives, and we have a center at northeastern region called NISAC, Northeastern Space Application Center, and they are the nodal agency for this particular activity, and they have capability for unmanned aerial vehicle based disaster management support, which helps them generate very high resolution digital elevation model or damage assessment. And under this NERDRR initiative, we are also trying to develop some sort of, research into developing nowcasting system for lightning or thunderstorms in the region. And as you know, capacity building and international engagements are also very important aspects of disaster management support program. We frequently conduct training programs for various government officials of government departments, and now we have also associated with various academic and research agencies in the country, so that their particular strength could be utilized for disaster management support. And we are also carrying out, joint research development activities with various IITs and all, so that we can develop newer applications for disaster management support. And I would also like to mention that we are engaged in various international engagements, international initiatives for disaster management support. One thing I can mention is International Charter. It's a initiative of about 17 global space agencies, and it's a no-profit initiative. And if there is a disaster, the international charter is activated so that all these agencies share their satellites for acquiring satellite-based information for disaster management support. So I think I have covered almost all the aspects, though I took slightly more time here. So I would like to just move to the next segment, that is how space is supporting the climate change studies. And climate is a result of interaction between amongst sun's radiant energy and with various earth systems like ocean, atmosphere, and land. And by definition, if you see, the weather is basically the state of atmosphere at a given place and time. And you need a lot of variables to define this weather, whether it is the temperature, pressure, air, movement, precipitation, wind velocity, then also the composition of atmospheric composition at that point of time. And it's a very variable phenomenon. Weather is a variable phenomenon. And how do you represent this weather information? You can have a, uh, an instantaneous observation, but since it is a varying phenomenon over a period of time, you will have a large database of weather observations. And basically climate is nothing but it's the average of weather events over a long period of time. So and you can see that obviously there are changes. You experience a different weather over a period of, with the passage of time. And basically it is because of some changes in the system, the earth system as such. And you can also see that the atmospheric composition wise, uh, the trace gases constitute only 0.1%. Even in that one, carbon dioxide is the major constituent, and along with methane. And why these two are important? Because these are the important greenhouse gases which also control our Earth's temperature. So you can how the satellite data is helping into the weather, or what is ISRO's interest? I would like to brief. Before that, I can just mention that there are some agents which indicate change of climate. For example, if you see, I was explaining about carbon dioxide. If you see the measurement of carbon dioxide, the latest measurement is about 427 ppm, and you can see from 1960 it is showing an increasing trend. And how significant, what is the role of this one? Because being a major greenhouse gas, the concentration change is actually contributing to the warming of the earth actually. Then we also, in the lower left side, you see the observation of methane. These two observations, whether carbon dioxide and nova, and methane, both are from the US side. And you can see that the methane concentration is about 1932 parts per billion. And one thing you can notice here is that these concentrations are in very minute levels, either in parts per million or billion. So observation of these parameters require very high observational capabilities. And what are the indicators of their increase in the atmospheric composition? You can see that 2023 was recorded as the warmest year during the last 47 years, and this year 23 was nearly 1.3 degree warmer than the period pre-industrial period of 1850 to 1900. So that it is indicating that there is a warming up. So there is an agent which is causing some sort of, and it is indicated by some parameter. And you can also see that lower right side, you can see that there is a change in the sea level. And this figure 103 millimeter is since 1993. So 2003, nearly 22 years, it has shown an increase of about 10 centimeters. So this is another indicator. You have temperature warming, you have increase of sea level. And I will move on here. This graph, if you see this picturization, is from the IPCC's sixth assessment report. What you see here, up to 2020, there is an increase of about 101.1 degrees Celsius over the pre-industrial period temperature of average pre-industrial period of 1850 to 1900. That was 1.1 degrees Celsius. Now, if the future emissions are not really contained, or if the future emissions are really not really taken care, what is going to happen here? You can see the color coding here. By 2100, by end of century, if the emissions are going to be high or very high, you are going to end up in a very high global temperature change over the 1850 to 1900. So who is going to suffer? The current generation, which the generation starting 2020, by the time they reach 2100, they will be facing such extreme temperature. So there is, suppose if we are able to contain the emissions to very low level, then it may be that we are able to contain that temperature rise to almost maybe almost up to 1.5 or that type of temperature range. So it is important that I'm just trying to explain how significant this climate change, the indications, and what are going to be the impacts. Now, what are the impacts? You can see that if there is significant adverse climate change, it is going to affect the water availability and food production. Then physical water availability could be in both ways. It could be a drought, or it could be extreme. There could be melting of glaciers. So it is, if you can see the legend, there is a green hatching and red color. Red color means negative impact, and green hatching means positive. So agricultural crop production is going to be negatively affected. Then fisheries is going to be negatively affected, and all the health and well-being parameters are also going to be badly affected. And then obviously all the cities, settlements, and infrastructure, we are going to have floods, inland flooding, damage to infrastructure, and all. And on the lower right side, the biodiversity and ecosystem, though they show some sort of influence by change of climate, but there is no trend actually evolving, especially for terrestrial ecosystems or freshwater ecosystems. Now, just to summarize, some of the indicators, like there is a temperature rise, there is precipitation changes, both in terms of extreme precipitation and as well as in terms of lack of precipitation, and there is indication of sea level rise, And also there is another significant indicator is ocean pH. That means ocean is turning into acidification of ocean, which is also very harmful, because as the ocean becomes acidic, all these shell organisms which have calcium will get their shells will be disintegrated through the acid's influence, and it will be destruction of such organisms in the ocean. So what are the impact? You will have impact of all these indications. You will have glacier melt and receding snow cover. There will be increased risk of flash floods. There is a decrease of soil moisture, decrease of agriculture productivity, inundation of, if there is sea level rise, it's going to result in inundation of low-lying areas, coastal marshes, then delta areas, which is really a typical ecosystem uh, between the river and between the freshwater and seawater. Those delta will be threatened by flooding and also saltwater intrusion. So these are the impacts, and how uh, we are actually going to uh, now the thing is clear, the Earth's climate is changing, but what is important is that whether we can assess the rate of such change, and whether we are able to find out the causes and what is going to be the future. So as I was telling, the system is complex. It is not a linear system. It is an interactive system. You have atmosphere interacting with the land surface parameters. You have interaction between atmosphere and ocean. You have interaction between land and atmosphere, and there are also uh, the influence from the anthropogenic influences, like our activities of vehicular pollution, or even the use of, use of vehicles, then industries, and all these release of carbon dioxide, even rice cultivation also, there is a release of methane, which are all getting uh, you know as parameters into the system, and then assessing the change is very, very crucial. So now what is really important is that we have to measure such small changes associated with the long-term global climate changes. And there is an initiative, something called the Global Climate Observing System, or GCOS, and it is an initiative of World Meteorological Organization, and they have identified nearly 55 parameters, what you define as essential climate variables, which can probably define the the status or the state of the climate. So basically we need to continuously monitor these essential climate variables. So uh, our what is our role is basically to map the indicators of change. We have to monitor the agents like greenhouse gases, then the terrestrial carbon, atmospheric aerosols, etc. And also whether we can model the impact. So the indicators, agents, and impacts, the study of all this through identification of continuous monitoring of essential climate variables is very important. Now, what is ISRO's interest? ISRO has actually, and I would also like to mention that uh, about nearly 50% of these essential climate variables, that is about 27 or 28 variables, are amenable to space-based observation. That means you can have some sort of assessment or at least partial observations of these ECVs using space-based inputs. So, having understood this, ISRO has initiated something called National Information System for Climate and Environment Studies, that is called NICES. It is hosted at National Remote Sensing Center, and the purpose of this initiative is to create national level long-term biogeophysical products for terrestrial, ocean, and atmosphere parameters. And this is not an isolated initiative. It is in partnership with various institutions in the country, like Ministry of Environment, Forest and Climate Change, or Ministry of Earth Sciences, CSIR, and other research institutions. And this basically, the NICES initiative consists of assessing the ECVs and other space-based products using observational network, satellite data, and also calibrating and validating these observations. So this is how the observations are actually, the observation cycle basically. You have the satellite-based observations, and these need to be validated using ground-based observation. And finally, if there are complementary data, then input these complementary data and finally derive outcomes. And both space-based inputs as well as ground-based observations are actually supporting this initiative. And I can what I would like to state here is that out of there are 55 ECVs identified by GCOS, and our NISES is able to assess. So far, we have developed 13 of such essential climate variables. But in addition to that, we also have developed 57 biogeophysical products, which could later, some of them could be later, basically these parameters need to be calibrated, validated, and need to have sufficient accuracy and precision to become essential climate variable. So we are in the process of making these some of these biogeophysical products also into essential climate variables. And you can see that the current 13 ECVs belong to like atmosphere, then cryosphere, the anthroposphere, biosphere, hydrosphere, as well as the ocean related ECVs like wind vector, wind stress and wind direction. And then for the land, we have land cover, forest fire, soil carbon, soil moisture, lake water extent. These are the land-based ECVs. And then for ocean, we have the chlorophyll concentration derived from satellite data. And in addition to that, there are instrumentations across, established across the country, and there are about 18 types of instruments placed at 90 locations. So this is about the NISES, and we are in the process of developing some of the other ECVs like ozone, surface albedo, and dissolved inorganic carbon. And then we are moving to developing other ECVs also. So maybe around 27, 28 ECVs could be generated in the next 10 years. That is the aim. And that I'm showing is some of the ECVs. Like this is available in our website, NRS's Bhuvan website. So this ECV is actually lightning is one of the ECV parameter variable, and you can see that on 11th June how the lightning very like a number of cloud to ground the lightning flash occurrences that is detected from the ground based lightning detectors, lightning detection sensor network established by NRC. About 46 such lightning detectors are there in the country established. So then this is actually about the wind vector velocity from our OceanSat-3 scatterometer. And then some of the other parameters like chlorophyll concentration. These are all available. These products are available at the NISES portal hosted at NRC. And then I would also like to bring it to your notice that our satellites, Indian remote sensing satellites, are being used, were used, and are being used for developing these parameters. Like for terrestrial observations, we had earlier the IIRS series of satellites. Basically, all these are not current satellites. This includes both previous, because for climate variables you need long term. So we had been generating these parameters like vegetation, land use, etc. from the IIRS series 1A series onwards, and we have the current ResourceSat 2A satellites are also supporting to this one. And like the radar imaging satellite 1A is we are using for soil moisture generation. Similarly, our satellites for ocean parameters, we are depending upon currently our the INSAT series of satellite. We are generating the sea surface temperature. We have now OceanSat-3 satellite giving the ocean color as well as ocean surface wind vector. And similarly, our weather monitoring satellites are also helping to derive various atmospheric parameters like the aerosols from ocean satellite, or the temperature humidity prevails from INSAT series of satellites. So satellite data, Indian as well as both foreign data, are being used for generating various products which are related to climate change. So it is not only from our side, globally also there are very good observation capabilities. Like NASA has got something called the Orbiting Carbon Observatory, OCO2, which was launched in 2015, and then OCO3 launched in 2019, and you can see that it is measuring the atmospheric carbon dioxide. Then there are a set of instruments called altimeters that are used for generating the sea level. So it is not one-time observation; it's a long-term observation, so that it becomes a climate quality data. And also the methane is now being observed by a satellite called EMIT. This EMIT is actually an instrument on the International Space Station. So that is the spectral data is actually used for deriving the atmospheric methane. So I can also mention that some of our upcoming satellites, I was telling about the ResourceSat series. So we are going to have the next generation ResourceSat satellites. We are also going to have like space-based stereo imaging with the next generation stereo imaging, which will give about 1.25 meter resolution stereo image, so that you can generate a digital terrain model for the country. And we are also anticipating some mission with the NASA, that is NASA ISRO Synthetic Aperture Radar, or NISR mission, which has both the L and the S band synthetic microwave payload on it. And this will basically give all weather as well as day and night imaging for the whole country every 12 days. And we also are going to have a complementary satellite for our OceanSat 3 satellite. We will be moving to the next generation INSAT series of satellite, that is fourth generation INSAT, which will be very good for the atmospheric observations. So for way forward, if you look at for disaster management, we will be we need to have enhanced understanding of some of the disasters. We also would like to have a better infrastructure for earth observation. Maybe that on the satellite itself, the data is processed and information comes down to the user. Then we need to also better preparedness and effective response should be available. Then we need to have the risk reduction. We need to risk assessment. We need to assess at the community level, and we also have to adopt best practices that are available at the international level. Then for climate change, as I was telling, what is important is the continuity of observations, as well as we need to have observation capabilities. What we are developing now is a capability for observing some of this atmospheric composition, like methane or carbon dioxide. Then we are developing millimeter wave humidity and temperature profilers, and we also are in the process of developing new models for retrieving the parameters. Then it is also important that the intercomparison of satellite-based observations, because since these parameters are global in nature, we need to compare our observations with whatever observations we are getting from other global constellations. And collaboration with other space agencies is also important. And I would like to mention that under India's leadership in the G20 initiative, one G20 satellite is proposed, which will be going to give very good observations. Many payloads related to atmospheric observations are planned in this G20 satellites. So I would like to stop here. I think almost 1 hour I took and covered, at least in a nutshell, I was able to probably highlight how space is supporting disaster management as well as climate change parameters, measurement of climate change parameters. And I thank all of you for you are this is kind of being aware of what is happening is very important, because usually we see a satellite is launched and we don't really know what is really happening with these satellites, how it is getting used. So we request you to trigger the students' interest in the students, so that they will be able to contribute, because they have very vibrant and creative mind. So they will find newer ways of utilizing such data or information. So we we would like to look at you in as our ambassadors for carrying this information to the next generation. Thank you so much.